You think your house is moving. You drive to work. You walk to the store. But none of that is real movement. Right now, this second, you're being dragged through space at 600 kilometers per second. Not by your car, not by the Earth spinning, by something so massive we cannot even see it. 600 kilometers per second toward a point in the southern sky, toward Centaurus, toward what astronomers call the Great Attractor. And here's what nobody talks about. We only figured this out because one side of our galaxy was warmer than the other, less than 1/100th of a degree Fahrenheit warmer. That tiny difference told us everything. Our entire galaxy, 100 billion stars, is falling. Also comment from which city you are hearing this from. Also, this script is researched and factual, using sources from the Carnegie Institution's Astrophysical Journal publications from 1987 and 1988 by Alan Dressler and the Seven Samurai team, the Nature Journal article, The Laniakea Supercluster of Galaxies by R. Brent Tully and team from September 2014, the Cosmic Flows 4 survey data published in 2023, and the Clusters in the Zone of Avoidance X-ray project findings from 2005. These are the people who mapped what we cannot see. Now back to the information. There's a deviation, a pull. 1978, more reports. The numbers do not add up. Something massive is out there, tugging at everything around it. But where? The Milky Way blocks the view. 20% of the entire visible sky is obscured by our own galaxy's dust, gas, and stars. They call it the Zone of Avoidance, and whatever is pulling us sits right behind it. For years, nobody can see it. Nobody can measure it. All they know is the pull. We are moving relative to the background radiation itself. The calculations come back, 600 kilometers per second, over 2 million kilometers per hour, toward Centaurus, right where we cannot look directly. The region sits in the direction of two constellations, Triangulum Australe, the Southern Triangle, and Norma, the Carpenter's Square, both in the southern sky, both obscured by the Milky Way's plane. Astronomers need a new approach. Visible light will not work. The dust is too thick. Alan Dressler from the Carnegie Institution, Sandra Faber, David Burstein, Donald Lindenbell, Roger Davies, Roberto Turlevich, Gary Wegner. They study 400 elliptical galaxies. They measure peculiar velocities, motion that cannot be explained by universal expansion alone. The data shows coherent bulk motion, 570 kilometers per second toward Centaurus. All the galaxies are streaming toward the same point. Dressler coins the name, the Great Attractor, officially cataloged as ACO 3627, Able 3627. One of the most massive clusters in the nearby universe. Distance, 200 to 250 million light years. It sits almost exactly where the Great Attractor calculations pointed. They quantify the attractor's influence using velocity data from hundreds of galaxies. The model predicts a mass concentration of 10 to the 16th solar masses. That is 10 quadrillion times the mass of our Sun, 50,000 times the mass of the Milky Way. All concentrated in one region, the infall velocity, 600 kilometers per second, exactly matching the cosmic microwave background measurements. As infrared and X-ray data improves through the 1990s, the numbers do not match. The Norma Cluster is massive, yes, but not massive enough. Not 50,000 Milky Ways massive, not even close. The Great Attractor should contain more than what they are seeing. Either the mass estimates are wrong, or something else is going on, something bigger. A team conducting the clusters in the Zone of Avoidance project, CESA, releases X-ray survey results. The Great Attractor has only 1/10 the mass originally estimated, 1/10. The Norma Cluster and surrounding structures add up to maybe 5,000 Milky Way masses, not 50,000. So what is pulling us? The survey reveals the truth. Behind the Great Attractor, 650 million light years away, sits something far more massive. The Shapley supercluster. He notes its great linear dimension, the numerous population, and distinctly elongated form. Then it is forgotten for 50 years. Exactly what Shapley said 51 years earlier. 1989, Somak Ray-Chaudhuri at Cambridge University names it formally, the Shapley supercluster, in recognition of Harlow Shapley's pioneering survey. The same year, Roberto Scaramella and team identified independently in the Abell catalog, they call it the alpha concentration, at least 25 major galaxy clusters. 7 of those clusters rank as richness class 2 or higher. That means they are as rich as the famous Coma and Perseus clusters. The 3 richest are Abell 3558, Abell 3559, and Abell 3560. They sit at the core. These are some of the most massive galaxy clusters known anywhere. Abell 3558 alone contains more galaxies than the Coma cluster. The total mass, equivalent to 10,000 Milky Way galaxies, maybe more, all packed into a volume comparable to our local Virgo supercluster. It is the largest concentration of matter within 1 billion light years of Earth. The direction we are moving, the peculiar velocity measurements confirm it. Our local group is being pulled not just by the Great Attractor, but by Shapley beyond it. The combined gravitational influence explains the 600 kilometers per second motion. The Great Attractor acts as an intermediate node, a waypoint. The real destination is Shapley. Brent Tully at the University of Hawaii leads a team studying galaxy velocities. They use the Cosmic Flows 2 catalog, over 8,000 galaxies with measured peculiar motions. They apply a technique called Wiener filtering. It smooths out individual uncertainties and reveals large-scale flow patterns. What they discover redefines our cosmic address. The Laniakea supercluster of galaxies. Tully, Hélène Courtois, Yehuda Hoffman, Daniel Pomered. They map the gravitational basin containing our galaxy. They define it not by density, but by motion, by velocity flows. Galaxies within the basin move toward a common center. That center is the Great Attractor. The basin spans 520 million light years. It contains 100,000 large galaxies. Total mass, 10 to the 17th solar masses. 100 million billion suns. They name it Laniakea, Hawaiian for immense heaven. The Norma wall runs through it, containing the Norma supercluster and the Great Attractor region. All these structures are connected, all flowing toward the center. The Milky Way sits on the edge, about 50 megaparsecs, 160 million light years, from the Great Attractor. We are falling in from the outskirts. Beyond the boundary, galaxies flow toward different attractors. The neighboring superclusters are Perseus Pisces, Hercules, Coma, and Shapley. Laniakea is one basin. Shapley is another, larger basin. And here is the catch. Laniakea is falling toward Shapley. The bulk flow at 150 megaparsecs is 315 kilometers per second, plus or minus 40. The data reveals structures potentially 10 times larger than Laniakea. These basins of attraction suggest our cosmic journey operates on scales previously unimaginable. The probability that Laniakea is embedded within a larger Shapley basin, 60%. If confirmed, our cosmic neighborhood expands by a factor of 10 in volume. The Great Attractor's pull is part of a dipole dynamic, a push and a pull. On the opposite side, there's a void, the dipole repeller, a region of space with far fewer galaxies. It is not just that Shapley pulls us, the void behind us pushes. Gravity works both ways. Dense regions attract, empty regions repel. The motion we observe is the combination of both forces. Right now, Earth spins at 1,600 kilometers per hour. Earth orbits the Sun at 108,000 kilometers per hour. The Sun orbits the Milky Way's center at 828,000 kilometers per hour. The Milky Way moves toward Andromeda at 200,000 miles per hour, over 320,000 kilometers per hour. And on top of all that, our entire local group of galaxies is being pulled toward the Great Attractor in Shapley at 600 kilometers per second, 2,160,000 kilometers per hour, 1.3 million miles per hour. Every second you exist, you travel 600 kilometers closer to Centaurus. You will never feel it. You will never see it. But it is happening. If you value documented cosmological dynamics and gravitational basin mapping like this, subscribe. It is the best way to support our work. Also comment from which city you are hearing this from. Also, this script is researched and factual, using sources from the monthly notices of the Royal Astronomical Society. Publication on the Norma Cluster Dynamic Analysis by Kron Korteweg, and teams from December 2007, the European Southern Observatory's Planck satellite data on the Shapley supercluster from October 2013, and Wallaby radio survey findings from the Australian Square Kilometre Array Pathfinder, published in 2024, showing 27 new galaxy counterparts in the zone of avoidance region. These observations use 21 centimeter hydrogen emission lines to map hidden structure. Now back to the information. The zone of avoidance covers 20% of the sky. Along the Milky Way's galactic plane, the view is blocked. Stars, dust, gas. At visible wavelengths, extinction is severe. The dust dims sources by more than 25% in optical light, about 10% in infrared. Right in the thickest part, behind the galactic center, we see almost nothing. This is where the Great Attractor sits, 7 degrees off the galactic plane. Close enough that dust obscures most of it, far enough that some observations get through. The intercluster medium, heated to tens of millions of degrees, radiates X-rays. Each wavelength reveals a different piece. 2016. The discovery of the Vela supercluster is announced. It spans the galactic plane, hidden from view for decades, about 800 million light years away, potentially as massive as Shapley. Its influence on local bulk flows is comparable. They map hydrogen across the zone of avoidance. 27 new galaxy counterparts detected. The mystery mass gap shrinks by 15%. Each new detection refines the mass distribution models. Each one brings us closer to understanding what is really pulling us. Temperatures in the intracluster medium reach tens of millions of Kelvin. The gas contains heavy elements, iron, silicon, products of supernovae. The cluster contains a preponderance of large, old galaxies. Many are colliding with their neighbors. They radiate large amounts of radio waves. The cluster's velocity dispersion, 1,000 to 1,500 kilometers per second. That tells you the depth of the gravitational well. How much mass is there? How fast galaxies move within it? The cosmic web on the largest scales. As galaxies and clusters flow out of voids and into dense regions, the motion looks like push and pull, attraction from dense regions, repulsion from empty regions. Both forces shape the flow. Motion away from the dipole repeller adds to the overall velocity. Combined effect, 600 kilometers per second toward Centaurus. The cosmic microwave background measurements, the galaxy velocity surveys, the X-ray observations, the hydrogen mapping, all the data lines up. To produce the observed velocities, you need more mass, about 10 times more. The solution, dark matter. Invisible mass that does not emit light, does not absorb light, only interacts through gravity. It fills the spaces between galaxies. It forms the gravitational scaffolding for all large-scale structure. In Laniakea, dark matter comprises 80 to 90% of the total mass. The galaxies we see are just tracers, markers showing where the dark matter concentrations are. 10 quadrillion suns, but spread across hundreds of millions of light years, diffuse, concentrated in filaments and nodes, not uniform. The Virgo supercluster, our old cosmic address, spans 110 million light years and contains 100 major galaxy groups. Laniakea, our new address, spans 520 million light years and contains 100,000 large galaxies. Shapley, the structure pulling Laniakea, sits 650 million light years away and contains the mass of 10,000 Milky Ways packed tight. The Perseus-Pisces supercluster chain, 300 million light years from us, connected to Laniakea by filaments, the Coma supercluster, the Hercules supercluster. All nodes in the cosmic web, all moving, all flowing along the filaments, all falling into basins of attraction shaped by the largest concentrations of dark matter. Evidence for structures potentially 10 times larger than Laniakea. Basins spanning billions of light years. If confirmed, our understanding of the maximum size of cosmic structures must change. The standard cosmological model, lambda CDM, predicts an upper limit. Structures should not exceed a certain size. The universe has not had enough time since the Big Bang for larger structures to form through gravity alone. But observations keep finding structures at or beyond the theoretical limit. The Big Ring, 1.3 billion light years across, discovered in recent surveys, challenges our models. The Shapley Attractor Basin, potentially 10 times Laniakea's volume. If real, it exceeds predictions. Unknown forces, alternative theories of gravity, or dark matter behaves differently than we think. Different distribution, different clumping, 20% variation from models. That is what recent 2025 analyses suggest. Dark matter's clumpiness might vary more than we assumed. That could explain some of the discrepancies. Cosmic microwave background shows it. Galaxy velocities confirm it. The direction? Centaurus. The destination? Great Attractor region within Laniakea, ultimately toward Shapley. The question is not whether, the question is what happens next. It accelerates over time. Right now, within Laniakea, gravity wins. The basin is temporarily anchored. Galaxies flow inward faster than expansion pulls them apart. But Laniakea is not gravitationally bound. It is too diffuse, too spread out. Over cosmic timescales, billions of years, expansion wins. The supercluster will disperse. The galaxies will drift apart. Currently, the Great Attractor's gravity is still enough to pull the Milky Way toward it. That will be true for a few billion more years. But dark energy is pushing the Great Attractor region farther away from us. Eventually, the distance will be too great. The gravitational pull will weaken. The expansion will dominate. Instead of the Milky Way being drawn toward the Great Attractor, it will start moving away. Recession will replace attraction. In about 4 billion years, another event happens. The Milky Way will merge with Andromeda, 2 galaxies colliding, combining into one massive elliptical galaxy, Milkomeda. By then, we will be even deeper within Laniakea's gravitational influence. Or maybe not. Maybe by then, expansion has already started pulling Laniakea apart. The timing is close, it depends on exact measurements, mass distribution, dark energy equation of state, all still uncertain. And that is just the visible mass. The dark matter halo is far more massive, perhaps 10 to the 17th solar masses, 100 million billion suns. Velocity field reconstruction, that is the key technique. Measure the peculiar velocities of thousands of galaxies. Apply filtering algorithms to reveal large-scale patterns. Define basins by where flows converge. Where do galaxies fall? That tells you where the mass is. And Shapley might be part of an even larger flow towards something else. Something we have not yet detected. Something beyond our current survey limits. The observable universe extends 46 billion light years in every direction. We have surveyed only a small fraction. Most of the universe remains unmapped, especially behind the zone of avoidance. The Green Bank telescope maps hydrogen at 21 centimeters, penetrates the zone, detects hidden galaxies. Meerkat in South Africa does the same. FAST in China, 500 meters across, the largest single-dish radio telescope. It detects faint hydrogen signals from galaxies billions of light years away. The Dark Energy spectroscopic instrument maps millions of galaxies, measures redshifts, traces the cosmic web in 3 dimensions. The James Webb Space Telescope looks in infrared, sees through dust, reveals galaxies at the edge of the observable universe. Combine them all, and the picture emerges: structure, filaments, voids, superclusters, basins of attraction, the cosmic web in full detail. We estimate about 10% of the sky remains truly difficult to survey. Even with infrared and radio, the extinction is just too severe, but 90% is accessible. And the data shows the zone of avoidance is not empty. Far from it. It is rich with structure, clusters, superclusters, filaments, all hidden behind our own galaxy's plane, the place where flows converge. Norma and Centaurus clusters mark the spot. But the real attractor is not visible. It is dark matter, a concentration of invisible mass, shaped by gravity over billions of years, pulling everything toward it. 600 kilometers per second, 2 million kilometers per hour, 1.3 million miles per hour, all moving toward Centaurus. You've been falling since you were born. You will be falling when you die. The distance traveled in a human lifetime at 600 kilometers per second is enormous. In 70 years, we move 1.3 trillion kilometers closer to the Great Attractor. That is about 140 light years, a tiny fraction of the distance. The Great Attractor is 200 million light years away. At our current speed, we would take over 300 billion years to reach it. But the universe is only 14 billion years old. And expansion is accelerating. We will never arrive. All the data points to the same conclusion. We are moving. We are being pulled. The Great Attractor is real. 1988, formal analysis quantifies the mass and location. 1990s, infrared and radio surveys begin detecting galaxies behind the zone of avoidance. 2005, SISA X-ray project reveals the Great Attractor has 1/10 the originally estimated mass, and Shapley supercluster is the real driver. 2014, Laniakea supercluster defined by velocity flows. 2023, Cosmic Flows 4 with 56,000 galaxies reveals structures potentially 10 times larger than Laniakea. 2024, Wallaby survey detects 27 new galaxies in the zone of avoidance. 2025, refined measurements from DESI and FAST confirm dynamical boundaries and dipole repeller effects. We are in a supercluster. That supercluster is defined by motion toward a common center. That center is the Great Attractor region. And the entire supercluster is being pulled toward the even more massive Shapley supercluster, 650 million light years away. Motion on top of motion. Flows within flows. The cosmic web revealed by velocity, not density. We are falling through space at speeds most people cannot imagine. And not just us, everything around us. All the nearby galaxies, all the clusters, all being pulled toward the same destination. The universe is dynamic, active, constantly in motion. Gravity shapes everything, pulls matter together, forms filaments and walls and superclusters, creates basins of attraction where galaxies flow like water flowing downhill. Dark matter makes it possible. Without dark matter, there is not enough mass to explain the motions, not enough gravity to hold superclusters together even temporarily, not enough to create the flows we observe. Dark matter fills the universe, 5 times more abundant than normal matter. It forms the skeleton, the structure on which everything else hangs. Galaxies form where dark matter concentrates. Clusters form at the intersections of dark matter filaments. Superclusters form around the largest dark matter concentrations. The Great Attractor is a dark matter concentration. So is Shapley. So is every major structure in the universe. We know the major structures, the superclusters, the voids, the filaments. We know how they connect, how they move. Beyond 1 billion light years, the picture gets fuzzier. The data is sparser, but even out to several billion light years, we see structure, superclusters and walls, filaments spanning hundreds of millions of light years, and voids, vast empty regions hundreds of millions of light years across. The universe is not uniform. It is structured, patterned, shaped by gravity acting over cosmic time. Clusters falling into superclusters, superclusters falling toward the densest regions, everything flowing along the dark matter, filaments toward the deepest gravitational wells. Eventually, each gravitationally bound structure, each galaxy cluster, each galaxy, maybe even each star system will be isolated, alone in an expanding universe. No neighbors, no flows, just precession. But that is billions of years away, tens of billions, maybe hundreds of billions. Every second, 600 kilometers closer. Every year, 18 billion kilometers closer. A distance so large it is meaningless to human experience, but it is happening. The motion is real. Each one adds to the picture. Each one refines the mass distribution. Each one confirms that structure continues across the galactic plane. The Vela supercluster is real. potentially as massive as Shapley. Its influence on our motion is significant. 50 kilometers per second of the local group's peculiar velocity attributed to Vela. Not as much as Shapley, but significant. But in terms of what we do not know, every new survey reduces the gap. Every new telescope reveals more. We will never see everything. The densest regions, right behind the galactic center, will always be obscured. But we can map most of it. Infrared, radio, X-ray, each wavelength reveals more. The goal? A complete three-dimensional map of all structures within 1 billion light years, including everything behind the zone of avoidance. That goal is achievable, maybe within the next decade, maybe 2. All questions that can only be answered with more data, more observations, more surveys. We will continue moving long after we are gone. The motion is part of the universe's structure, part of how gravity shapes matter on the largest scales, part of the cosmic web. The measurements come from cosmic flows, 4++ integrations using DESI and fast data. The dynamical boundary sits at 200 to 300 megaparsecs. Beyond that point, flows homogenize. The peculiar velocities average out. Universal expansion dominates. But within that boundary, flows are coherent, directed toward the densest regions. Push from the void behind us. The combined effect, 600 kilometers per second. The measurements are precise now. Error bars small. 50 years of observations have converged on this value, 600 kilometers per second. Plus or minus a few tens of kilometers per second, depending on the measurement technique, but always around 600. Always toward Centaurus. Always consistent. The measurement that makes it all real, the cosmic microwave background temperature difference, less than 1/100th of a degree Fahrenheit. That is how we know. That is how we measure. One side of the sky is slightly warmer, the side we are moving away from. The other side is slightly cooler, the side we are moving toward. The temperature difference is caused by the Doppler effect, motion through the radiation field. The same effect that makes a siren sound higher pitched when it approaches and lower pitched when it recedes, except with electromagnetic radiation instead of sound. Light waves compress in the direction of motion, blue shift, warmer. Light waves stretch in the opposite direction, red shift, cooler. The temperature difference tells us the speed, 600 kilometers per second. That measurement was made in the 1970s and 1980s. It has been confirmed countless times since, by different satellites, different instruments, different teams, always the same result. 600 kilometers per second toward Centaurus. It is one of the most precisely measured values in cosmology, because it is one of the simplest measurements, temperature difference across the sky. That is all it takes. And the result is undeniable. Since the first structures formed, since gravity started pulling matter together into filaments and walls and superclusters, we have been falling. We are falling now. We will keep falling until expansion overcomes gravity, until dark energy wins, until the universe tears everything apart. 1,000 to 1,500 kilometers per second. That is how fast galaxies move within the cluster. To hold galaxies moving that fast, you need tremendous mass. The virial mass calculation, several times 10 to the 15th solar masses, several million billion suns, just for one cluster. Rosat mapped it in the 1990s. XMM Newton refined the measurements in the 2000s. Chandra added high-resolution details, massive amounts of hot gas. The gas contains iron, silicon, oxygen, heavy elements produced in stars. Enrichment levels consistent with billions of years of star formation. Supermassive black holes consuming matter. The number of radio-loud galaxies tells you about merger history. Collisions trigger black hole activity. The Norma Cluster has many. Ongoing dynamic activity. Galaxies still falling in. But peculiar velocity matters. The Great Attractor's motion toward us reduces observed redshift. Actual distance, 150 to 250 million light years. Velocities. From that catalog, calculate peculiar velocities. Subtract cosmological recession from observed redshift. What remains is gravitational motion. Apply Wiener filtering to reveal large-scale flow patterns. That is how Laniakea was discovered. 27 new galaxies detected in the zone of avoidance. Each detection comes with hydrogen spectrum showing redshift and velocity. The mystery mass gap reduced by 15%. More galaxies found, more mass accounted for. It complements Wallaby. Different structures, same technique, same goal. Map the hidden universe. Longitude around 310 degrees near galactic center has worst extinction. 10 magnitudes or more at optical wavelengths. Light dimmed by factor of 10,000. But away from center, extinction drops. Radio penetrates everywhere. Latitude matters too. Right on the plane, extinction peaks. The Great Attractor at 7 degrees off the plane is just barely visible. We use machine learning to classify sources. We combine data from multiple wavelengths. And now in 2025, we have a reasonably complete picture of the local universe within 500 million light years. Laniakea, Shapley, Perseus Pisces, Vela, all mapped, all measured, all confirmed. We mapped the structure causing the motion, we measured the mass, We identified dark matter distribution. We defined our cosmic address within Laniakea. We discovered Shapley beyond it. We realized motion comes from combined effects of multiple attractors and repellers. We built the tools to see through obscuration and map the invisible. Velocity reveals forces, maps mass, defines structure. Every galaxy's spectrum encodes velocity. Measure enough galaxies, apply the right analysis, and the cosmic web appears. Filaments, walls, voids, basins, all revealed by motion. Gravitational focal point of Laniakea, pulling us and 100,000 other galaxies toward it at hundreds of kilometers per second. Dominated by more distant Shapley, all part of the cosmic web. Large-scale structure formed by gravity, acting on dark matter over billions of years. The largest structures in the universe, cosmic evolution, written in the motions of galaxies, confirmed by every measurement, 600 kilometers per second toward Centaurus, toward the Great Attractor, toward our cosmic destiny.